Hey everybody, this is Larry. This is October 2nd in the year 2024. Basically, I try to do a problem that I haven't done before sometimes randomly. So let's take a look and let RNG guide us. We have 1586 binary search tree iterator 2. Implement the BST iterator class that represents an iterator over the in-order traversal of the binary search tree. Okay. Has next, has previous. I'll always be right. There'll be all. Okay. Yeah. Pre-calculating the values of the tree. What does that mean? I wasn't going to. I was just going to. I mean, I guess if you did. I guess the lazy thing would have been just to take a look at the tree and then put it in an array and then implement everything from that array. But you can also do it. I mean, there's also the thing that this always comes up, which is the Morse traversal. I'm not going to do that because I don't know. I always feel like that is not in the spirit of things. But yeah, I mean, I think the way that I would think about this is just to I don't know if you can hear that, but that's just the doorbell from next door. It's kind of loud sometimes. But yeah, the way to kind of think about this is just to do it with depth first search, right? Is the way to do it. And the way to do that, in general, is by recursion is the easiest, but at least to me. But it is just by using an implicit stack, and we can just keep track of that stack, and I think that should be good, right? So stack, we just start with the root, and I think in theory we should be good. Right, I might have to work that out. To be honest, I don't implement the depth first search of stack very often, so I may kind of struggle a little bit. But we'll play around. I mean, the idea should be sound, though, right? So then has next is that basically in order we want the left, we want the node, and then the root, right? So maybe we want to. I don't know if I want to put in the state, right? So here we just. Actually, this isn't quite right either anyway, but what we want is that while self.stack of -1, well, this will always be greater than 0 because of the way dot left is not none, then self.stack.append self.stack dot left, right? Basically, you're now just going to the left all the way, and this gives us that, right? And then has next. Well, we always have a have next unless stack is empty. So return. I think. Oh, has previous. I have to do the is previous part. Oh, we have to go previous. Oh, I am maybe wrong then. I missed. Oh, I just skipped reading it a little bit, honestly. Usually an iterator doesn't go back and forth though, which is, I mean, usually it just goes one way in, well, one of the ways anyway. But that's why I kind of, I don't know. Move the pointer to the left. What does the left mean in this case? I mean, to the left and to the right is a little bit awkward phrasing. I think they mean the next, like, next biggest number and the previous biggest number, but it's to the left and to the right is a little bit awkward phrasing. Okay, so let's say the state is, let me read this. Okay, next is 3, 7, previous is back to 3. Yeah, okay. I mean, I see what they mean now. It is a little bit tricky. Okay, let me reset it a little bit. It's hard. I mean, I think you can. There are definitely ways to do it. But it's all just bookkeeping and keeping track of things. I don't think this is that hard, but it's just very annoying for sure. I think this is a good thing to start anyway. Right, so then now we have everything to the left. So now the top of the stack is the current number, and to get the next, we actually I think my problem is that it's not clear to me that I can do the next operation O of 1 or even O of log n. Because if you have this case, for example, if you go from 7 to 9 and then 9 back to 7 and 7 to 9, I mean, and you have a more extreme case, it would just like go up and down and up and down and up and down, right? So I'm not and yeah, in this case also I was wrong about Morse traversal because I just didn't read this correctly. So I don't know, to be honest. I mean, it's not that hard, but it is also not, you know. Because they never said that this is going to be a balanced binary search tree, right? Just a regular binary search tree, which can get very unbalanced, even though it's binary search tree. Because you can imagine a case where, yeah, just like a long linked list, and then like, or something like that, and then like one that goes there, and then you just keep on going back and forth, and you kind of keep track of it that way. You're gonna have a bad time. I'm not gonna lie, I don't think I know how to do this the non-cheesy way, so I'm gonna do it the cheesy way and then we'll figure it out. Can I figure it out? Let me spend like 1 minute to give it a thought. I don't know if I know this one. Like, do I have a way to resolve that without pre-calculating or like skip pointers or something like this? Right, and I don't know. All right, let's just do it the lazy way, and then we'll figure it out. Right, so self dot away is right. So then now we have a depth first search on node. If node is none, we return. Otherwise, we dfs node dot left self dot away dot append node dot value. I was debating whether I need node dot value or whatever, or node itself. I think this is fine, right? And we'll just go in order. Yeah, and then in order root, and we should be pretty Gucci. And then just like a current index, it's at 0. And then has next, we do self dot index is less than this, right? And we could probably just cache that as well. Because this is the next pointer. Maybe it's a little bit awkward, I don't know. But then now we return self.index. This is the return thing, and then we return R, but then obviously increment by 1. Has previous is, so if it's at 0, it has a next, but it doesn't have a previous, right? So return self.index to the 0 or greater than 0. Yeah. And then previous is we actually subtract 1 first, the way that we do it, and then we can return it. I mean, doing it this way should not be that bad. Apparently, I'm wrong though. This is just way wrong. We have 3, we have 7, so we do, and then we're at 9. Okay, so we are pointing at the next. So to get the previous is something else. I'm off by 1, because basically, I mean, we could probably simulate it the way they do it too, but I was a little bit. Okay, so then if this, let's see, we run from 3, we run to 7. So then now, because we increment, we're at 9. Okay, so we do next as 9, but then if we want to get the previous, we actually have to subtract by 2, and this is like greater than 1, I guess. It is way awkward, honestly, and this is apparently not right. Maybe this, but now I'm just like trying random things. But then this keeps the state correctly, while of which one is the next one, because the next one is still going to be self.index, because now we're going 2 back, right? Anyway, let's give it a quick submit, see if we're right. Apparently I haven't done this one yet, so oh well, I mean, of course, because that's the idea behind this RNG thing, so that's good. Yeah, I mean, that's basically what we did, even though I did it a little bit lazy. But iterative in order traversal. I mean, that's what I was trying to do with the stack, but it's not clear to me that, I mean, yes, the next call will be O of 1, but like here, even this graph, if you keep on going from 30 or 25 to 13 to 25 to 13, I don't know how you do it. Oh, I see. But I mean, so what they're saying is that they're memorizing instead, which is fine, because they're like, okay, we already store it, so we don't have to it's not pre-calculation, we're doing it live, so by caching, which is like kind of like a lazy, not lazy in a bad way, but just like lazy in a computer science sense, like lazy way of initializing, or lazy way to pre-calculate, which is a thing, but I thought there'd be something more clever, that's all. Okay, fine. Okay, fine. I mean, I get it, but I thought it would be something more clever. I mean, if you kind of want to say O of 1, then you could also say that pre-constructing it kind of the way. Pre-constructing it also is O of 1 per item amortized, right? I guess you can say that if you don't have enough next cores, then it doesn't get used, which is, I guess, good. But I actually didn't. I don't know. I mean, this is not the way that they did it was not hard. It's just that, even the iterative lazy initialization way. But it's just that I don't know if I would have expected them, or I wouldn't know if I expect that that's what they meant. I think that's the biggest drawback. And I am very glad that I did not spend that much time on this, because I would not have mind read it. I thought that maybe there'll be some like really clever way of understanding this problem with, like, I don't know. I see what I mean, yeah. For some reason, maybe I just thought they meant like all of one space in the same way, but I guess not. I just kind of didn't think about it that way. Where were the hints? Yes. Yeah, okay, fine. I mean, yeah, okay, fine. I guess it does give it a little bit better amortization, but I thought it was something more complicated. Looks like I played myself. Anyway, that is all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, take good mental health. Thanks for watching, everybody. I'll see y'all later and take care. Bye-bye.